last week we had used the toaster as an example of equipment that we were circuiting. I believe that's what we created here. So yeah, this was a toaster, and we were using the duplex receptacle family to feed that equipment. So if you go into the folder that I sent out last night, you'll go into the coffee equipment and you'll see all of these different PDFs. And these are all cut sheets for the equipment that we'll be using in the coffee shop. And so this is very typical. Typically, the architect or kitchen equipment designer or whoever will send you something. They may be named with what the equipment is. They may just be a bunch of letters and numbers. So it's your job to figure out what's what and to figure out how to power all this stuff. So we'll click on toaster and use that as an example for today. Okay, so this is the cut sheet or the spec sheet for the toaster. This one is only 2 pages long, which is nice. I'm sure that you'll see some of them are not quite as condensed as this. And that's a very common thing that we have to do is, search through these cut sheets to figure out what we need. That's a skill in itself. So this one's nicely laid out for us. It tells us over here in the technical data what the voltage is, what the phase is, how many amps it's drawing, how many watts it's drawing. Very nice. You might see for some of these that you don't get all of that information, so you have to calculate the ones that you don't have. But for this, we know it's going to be a 208 volt single phase feed, and it pulls 3,600 watts. And then the one other important thing to make sure that you're finding from all these cut sheets is how this is actually powered. So what we show now is just a duplex receptacle, which is, by default, a 120 volt device. And that is just for any receptacles that you're plugging in the wall that you're seeing there. Those are 120 volts. That's what they're designed for to be in the US. And that's so when you plug in a piece of equipment that needs 208 volt or try to plug in, it's not going to work at 120 volts. So we need to have another way to get this to 208 volt. And that's what this down here will tell you. It shows a symbol that looks like a plug, and it tells you, if you Google what 6-20p is, you get some more information. But this is basically a special type of receptacle that will be used to power this toaster equipment. So first thing to do is realize that we cannot just use this duplex receptacle family. We're going to need a separate family. So you can go up to Load Autodesk Family in your Insert tab. And this is just going to give you access to all of the different families that Autodesk has already created. Again, your firm might have standard families they like to use, but Autodesk is okay for our purposes. So I'll type in special recept, and then I see this here, special purpose receptacle. So I will click that, and I will click load. And now it's going to load that family into my model. And so the fastest way to change this out would be to go up here, and because that special purpose receptacle is in the same category, electrical fixtures, I can just click up here and click down here, and now you'll see the symbol changes, and I've got a special receptacle. And so here is where your Revit model becomes very smart and helps you do your load calculations. You can actually go into this family and this type and change it to be all of the power requirements that you need. So you'll see down here under electrical circuiting, it says that we have 120 volts, 1 pole, and 180 VA, and it's grayed out, so I can't click it. And I know that we need 208 volt single phase through 3,600 watts. So I've got to change that. And if I go to edit type, I will see here that I can change this. The best practice is to not change the standard one, duplicate it, call it toaster like we did before, so that you're only working on this specific type for the toaster. You can change it to 208 volts. You can change this to 3600. And then here is where you can change your load classification, which is what does your demand calculations like we were talking before. So since this is no longer a receptacle, because it's not, it's not that 50% rule that we were talking about from before, we have to use a different load classification. So we're not going to go into, every single type of load classification, because we're going to get, that will be too much information for this short period. But I did think it's important to show you how to change these so that you're using the different demand factors, because that will be what you use to size your equipment. So what I do here is I go into load classification. I click this little side button. This side button, there's 3 dots come up, and then I can change the load classification. So I go here, I click appliance. If I want to see what this is actually calculating, I can click these little 3 dots next to demand factor, and it'll tell me what this is actually using to calculate. So this is just going to be 100%. So it'll take 100% demand of this 3600 load. So I'll use appliance here. I'll hit apply. And now you can see that my 208 volt, 1 pole, 3600 VA. So this is actually still a problem. If you remember from last week's homework, that 208 volt requires 2 hot wires. So it's always going to need 2 poles. And since this is grayed out, we don't see number of poles or any way to change it here. We don't see any way to change number of poles or phase in this type editor. It means you have to go into this family to actually change it. So you can click here, click edit family. Now you are in that special receptacles family folder or file. You can click here, which is your electrical connector. And now you see where number of poles is 1. So if I was to change this to 2, it would go back into this model and basically change it to 2, which is what I want, but it's also kind of not what I want, because then I can't use this special receptacle for any family or any piece of equipment that is not 2 poles. So this is a very, we're getting deep here in the families, but this is an important thing to be able to do, is to change this family into a type parameter. So you can click this box here, family types. And then this shows all of those settings that we were able to adjust before in the type window when we were editing type. And you can add a new parameter here. So we can call this poles. And then we will select electrical discipline, which will bring up a list of all of the electrical parameters within Revit. We can go to number of poles. We can hit OK. And this will create a new type parameter that's associated with number of poles, which is this. So instead of changing this in the family, you can change it in the edit type menu. Okay, so that is set now. And then we hit apply. OK. The only last thing to do is to click this electrical connector again, and then you basically link this number of poles by clicking this little box all the way to the side that says associate family parameter to poles, which is what we just created. And now you'll see this is grayed out here. You can click load into project. Overwrite the existing version is fine. And now all of a sudden, you can change the number of poles for your type. So this toaster can be 2 poles now. Okay, so we've got a 208 volt single phase, aka 2 pole, 3600 VA receptacle for the toaster, and the demand load classification that we looked at before is calculating at 100%, but it's not actually calculating anything until we put it into our panels and associate it with the panel schedules, which is what we will do now. So we're going to be using this room back here as our electrical room. And to place your panels, you will go into your families dropdown, electrical equipment, and we're going to start with our 208 volt panel. And it'll list some of those standard types of panels. I'm just going to select 225 as a guess right now. You can change these later, but I will drag that over into my model. I was in the sheet view, so it wasn't letting me drop that. So now spacebar, flip it over. I've got a panel in my model. And then you can click that. You can see all of the parameters associated with your panel board. And then to create a panel schedule, you simply just go click the panel. It'll bring up this modify electrical equipment tab. You can click create panel schedule, use the default template. And now you've got a panel schedule associated with that panel that you put down. So from here, you can use some of the stuff we talked about last week about tagging this. So if you want to tag the name of your panel, you'll see this is the electrical equipment type mark tag. So it's going to be tagging the type mark. Let's see. I clicked edit type mark of this panel. We can just call this panel L. I like to call in a building where I'm using 480 and 208, I like to name the 480 volt panels with H's, maybe like H1, H2 if I'm using multiple, and then the low voltage panels or 208 panels as L, L1, L2. You can really name it anything you want. This is just a best practice thing. And so now you'll see that my tag comes up. If I want to get rid of this leader, I can click here and make it look a little bit nicer. I can click back on the panel if I want to get to the panel schedule quickly. You'll see the name didn't come up there, so you can go and type this in. And then here is where you'll actually be able to edit all of your parameters or specifications for this panel. So now we want to circuit this toaster on a dedicated circuit, which means it's on a circuit all by itself, to this panel L. So to do that, we will click the device. We will click power, which comes up here once you click that receptacle. And then it will give you a drop down to select which panel you want to actually put it on. And it's only going to give you options that work with the associated voltage. So for example, this receptacle, we just defined it as 208 volt 2-pole. So it's only going to show me panels that are 208 volt and that have spares of it, or that has capacity for a 208 volt 2-pole circuit. So I can click L here. And then if we go back to my panel schedule, you'll see where this circuit now has come up onto the branch panel. So you can click in here, you can rename it to toaster. And then this brings us to the topic of circuit breaker sizing. This is the standard rule of thumb to size your circuit breaker. So it kind of walks you, if we didn't have the power, it'll walk you through how to get that from amperage. And then it will show you for the circuit breaker size. It doesn't give that to us on the cut sheet. Some cut sheets will say MOP, MOCP, which is defined in these slides later, which I'll send out to you as a reference as you're doing your homework. But if you don't have something that tells you exactly what to use for your circuit breaker, the general rule of thumb is 1.25 times the amperage, and then use the next standard circuit breaker size. And the next standard circuit breaker size is something that you can go back and look at the cheat sheet that I sent you. There's also, I've listed the NEC section, which lists standard circuit breaker sizes. But again, this is why it's important to make sure that we're designing around real equipment and not just saying, oh, this is the 27 amp circuit breaker, because you're not going to be able to get one of those. So for this one, we would have 17.31 amps times 1.25, 21.64 amps. The next standard size is 25 amps. Then we can go back into Revit. Simply click here, 25 amp circuit breaker. It'll show your appliance load classification that you assigned down here, your demand factor there. And now we are rocking and rolling inside this panel schedule. So now what you're going to want to do is, you see this as a question mark. I think that's because we actually changed, this used to be that AC tag that went away when we changed the family. So what we're going to want to do is we're going to want to show the panel name and the circuit number on our plans that's associated with this receptacle. You can go and look at the Sephora project I sent in this example of how that, how on the power plans we're showing what circuit everything is on. So I will type TG on my keyboard to get the tag thing to pull up. It'll give me a list of available tags for electrical fixtures. Remember, my receptacle is an electrical fixture, so when I'm tagging, the tag's always going to be associated with these. And I can see circuit tag, and I can see panel tag, and type mark tag. So let's just go with panel tag. So this is giving me the panel that is associated with, and if I do another tag, and I select the circuit tag, that will say 1-3, which is the circuits that it's Revit now knows that this is linked, so I can tag it. But this does not look great, right? We want these to be able to be combined into one sort of tag. So to do that now, you're going to have to get familiar and dive back into that family editor so that you can quickly change, how these tags read. So if I go here, I'm clicking that electrical circuit tag. I go up, I edit family. I can click this, and I'm going to go up here to edit label. And now it gives me, again, all of these other parameters, all of the smart things that are associated with that electrical fixture that I'm tagging that I can include in this label. So right now it already has circuit number over here, and we want to add the panel name. So we can add panel. And if you ever don't know which one of these, if you don't know exactly what parameter to use, it's a process of elimination by going back and seeing where you associated that with in the model. So I click here, edit label, panel. I click this button, add parameter to label. I want the panel name to come before the circuit number, so I can click this button and it'll move it up. And then you can put a sample value in here just so that you can kind of see what it would look like in your family editor. So A-1, this is where it becomes a little bit of preference. I typically like to have it read, panel name dash circuit. So if you want to do that, you can write a suffix of a dash, apply. You'll see that it's getting better, but there's still like a gap here, which again, preference. I would like to get rid of this gap. So I can hit this down arrow on the spaces column, make it 0, hit OK, and now it's just a clear, panel dash circuit number, no spaces. I'm liking how this is looking. I can hit load into project, or I can hit load into project and close. While I'm still working, I want to hit load into project in case I have to come back here and make any more adjustments. This is giving me the option to load it into my model or that special receptacle family, which we were editing earlier, because I didn't close out of it. I'll load it into my model. I'll overwrite the existing version. Now I got my panel name and my circuit number, and I can go through and tag anything in my model now using this. So this is where it gets to be some preferences on how you're designing things. Some people are okay with just showing the circuit next to the device. Some people like to show a home run, which is an arrow that comes off of the device and points back towards the panel and hits and then points towards the circuit tag. So if I want to show a home run, I can go to Systems, and then I'll come up to here, my ribbon. I'll see Wire, and I can do either an arc wire, a spline wire, or a chamfered wire. This is all preference. Personally, I like to use arc wires. So I'll click that, and then you'll see there's a little like pink circle with an X in it. That's what you want to hit when you have your wire open. So you click that, you click again a second time, and then now you can see where your line's coming up. And then you click for a third time and hit escape, and now you've got this home run. If you want to edit it, you can go in here to these little grips. They look like little blue bubbles. You can bend down the arc. You can pull this, this way. It's good practice to aim the home runs back towards your panel that you're at, and then you can move this tag over here so that you're showing, okay, this special receptacle is going back to panel L1-3. Okay, so the other thing, that's the process that you're going to be going through for all of that equipment that I sent you. You're going to be doing those calculations, putting it into the device, creating types as you need to, manipulating the parameters as you need to get the voltage, showing a dedicated circuit, and making sure that it comes up on your panel schedule. So I got the toaster, 25 amps, 2 poles, that's done. I'm also asking you to circuit your convenience receptacles. So this, again, people will tell you different things, but I like to put no more than 6 convenience receptacles on a single circuit. And when I say 6, I mean duplex receptacles. So these are all duplex receptacles. I've got 1, 2, 3, 4, 5, 6. I could put all of those on 1. I could put them on 2. This is where you're an electrical engineer, you're a designer, you get to make these decisions. And the more that you are working, the more you'll figure out what you like and what makes sense to you. So I'm actually just going to circuit these 3 circuits, or this hallway of circuits together right now. So I will click this convenience receptacle. This looks like it's a mistake in my model because I see it saying toaster. I don't want toaster. It would actually bring it in at 500 VA if I did that. So let's see, are any of these other ones? These are all toaster. So these should all be standard duplex receptacles. So a quick way to do this, you can click something, hold down Control, click the other receptacles here, and then go up to this drop down, change them all to standard, and now all of those will be standard. So now when I click it, I can tell this is 180 VA, which is, again, that one section of code that I snipped out earlier. Convenience receptacles by the NEC are required to be 180 VA, and Revit knows that, and that's why the standard was already set this way. So I can click here, I can click power, and now you'll actually see this is a way that I like to actually edit what's going on in the panel schedule myself. It brings it up in this properties window. So I can see load name, I can see the circuit breaker rating. And if I don't want to go back to the panel schedule to change all this stuff every time, I can change it here. So I could say storage receptacles. And then if I wanted to change the circuit breaker, which I don't here, you could do that here in this window. So I'll hit apply. And now to add the rest of these receptacles to that circuit, I will hit Edit Circuit under this Modify Electrical Circuits tab. And then you'll see it gives me the option to add to circuit or remove to circuit. So under Add to Circuit, I'll just click all of the receptacles I want. They'll go from being half-toned or gray to black. And then I can go up here to Finish Editing Circuit. And so now all of those circuits are on the same, or all of those receptacles are on the same circuit together. So if I hold my tag over any of them, I can see that they're all L2. Again, this is something that comes to standards and preferences. You could either show all of these with a L2 tag next to it, or if you're familiar with the Sephora plans, you could show arc wires between all of these things. So you could go up here, you could see that little circle, pink circle with an X in it, draw your arc wire, and then do that to all of the receptacles. One trick to know of, if you like to draw arc wires, you can hold over one of the receptacles that's powered and hit tab, and it'll show you, these dashed blue lines that show all the circuits that are on that, or all these receptacles that are on that circuit. And if I click now, my left click, while that tab was showing up, I'll get these two little arc wire symbol and chamfered wire symbol. And then I can just hit arc wire, and now it does the circuiting for me. It draws the home run for me. And it's smart enough to draw the home run that's closest to the panel. And then I can tag the circuit. I can draw it here. And now you can clearly see, what circuits are together. And if I go back to my panel schedule, since I edited it earlier, it'll say storage receptacles.